Hello students, I hope you are doing good. So in this video, let us see some few more networking devices. The first networking device that we are going to study is about the bridge. Okay, so bridge is a device that allows to link or connect the two networks together. So in this slide, we have LAN A network and LAN B network. I can also call this as the subnet. Okay, this is also a subnet or the LAN segments. Two different LAN segments are there. Now what exactly this LAN segment? The larger network has been divided into sub-networks known as subnets or the LAN segment. This we have studied in the switch when I was discussing. Okay, so why we need to divide this large network into subnets or the LAN segment is because to maintain the traffic. Now what is this actually traffic is? Suppose when we have more number of computer systems in our network or more number of workstations in our network, when they try to transmit the data simultaneously, when they want to communicate with each other, there is a provision that the packets may collide with each other. Now what is this packet collide or collision is? The packets may crash with each other. Once they crash with each other, the messages becomes unuseful for us or there may be a loss of data in that packet. Okay, to avoid this packet collision, we need to maintain our traffic. So we need to divide our entire large network into subnets. Here also the large network is being divided into two subnets or the LAN segment. So in LAN A segment we have 4 computers and in LAN B segment we have 3 computers. Actually it is one large network with a capacity of 7 computers or the 7 nodes. Now sometimes it is necessary to divide the networks into subnet because to reduce the amount of the traffic onto the large network. Once the network has been divided, the bridge is the device that actually connects the two subnets and manages the traffic flow between these two different subnets. Now here also you can see this is a bridge. This is segment 1. That means this is one LAN segment or this is one sub network or subnets. Okay, this is the second LAN segment. So in this first LAN segment, 2 workstations are connected. In the second LAN segment, 2 workstations are being connected. Now let us see how exactly the bridge works. So the bridges are quite smart enough to know which computers are on which side of the bridge. That means this bridge is quite enough to know that station A and station B are into the segment 1. It is very well known. And onto the other side of this bridge, the station D and station C are the computers into the second segment. It is knowing very well. Here I can show you that example how the bridges are quite smart enough. Now this is a bridge. There are bridges being connected with the 3 segments. Means your entire network is being divided into 3 segments. It might be any number of segments it might divide. Okay. So in this segment 1 we have 2 workstations, segment 2 we have 2 workstation, segment 3 again we have the 2 workstation. Now suppose think that this is my source and this is my destination. So when the packet comes here, the bridge maintains a table here. So for this, this is what is your physical address or the MAC address. I'll tell you what exactly this physical and MAC address. This physical address has been present in the segment 3. This physical address is present in the segment 2. This physical address has been present in the segment 1. That means the physical address of this computer system is segment 3. That means that physical address is lying in the segment 3. Okay, this physical address is lying in the segment 2. This physical address is lying in the segment 1. Suppose think that this is a source and this is a destination. As the packet moves to the bridge will examine for the physical destination address onto the packet. Now what is this physical destination address is? In addressing there are 2 different addressing. One is the logical address, one is the physical address. Logical address is also called as an IP address. IP address we have lot of times before we have discussed with the so many hub and all we have discussed, wherein there it is using the IP address. Hub and switch we have used the IP address there. So Physical address is also called as, MAC address, that is media access control, okay, address, which is the address given to the NIC, that is the network interface card, okay, or the Ethernet card which is present in our computer system, okay, which is the address given by the manufacturer. Once your computer device was being developed, the manufacturer will give an unique address to your computer system known as the physical address or the MAC address. This is the address actually given to your NIC card or the Ethernet card. This NIC or the Ethernet card is responsible for your LAN connection or the internet connection. That is the port I have already shown in the Ethernet Ethernet card discussion video. In that I have clearly shown which is the Ethernet port or the NIC port. So the address given to that port is nothing but the physical address. And what exactly this logical address or the IP address is? Suppose if I want to communicate within the same network. Now this is actually one network into which so many computer systems, almost 6 computer systems are connected. If I want to transmit the data from within the same network, I need the physical address. Suppose if I want to communicate with the 2 different networks which are not in the same location, say suppose for example, if I want to communicate the friend of mine who is there in Bangalore city, if I want to transmit my packets outside my network, then I need the logical address or the IP address to transmit the packets outside from my network range. That time I need the logical address. Suppose if I want to communicate within the same network, okay, then I need the physical address. One example I can give. Okay, so if I want to communicate, I have in my computer lab I have 50 computers. If the computer 1 wants to communicate with the computer 50th computer, then communication is taking place within the same network. Okay, that time I need what? Physical address is enough. I need not to have a logical address, okay, because my packets are not moving outside my outside my network. It is the packets are getting exchanged within the same network, hence I need the physical destination address. Okay, now suppose if I want to communicate to the friend of mine who is in different city, then I need the IP address or the logical address. One more example I can give you is, suppose if you want to go to your neighbor's house, okay, if you want to go to your neighbor's house, you don't need any information like which city, which state, or what is the house number, what is the colony, what is the street. You don't need such information because you know physically where their house is. So directly you'll take the message and go to their house and drop your message there. This is what is the physical address, because first computer in my computer lab knows where exactly the 50th computer is located, hence it will directly forward the packet. Suppose if you want to meet to your friend who is there in different city and you are going to meet him, when you are going, what all information you collected, which city he stays, okay, which street in that city, which street, which colony, what is his house number, all these information you need. So that is what is the logical or the IP address. Whenever your packets is moving outside your city or outside your network, then you need this kind of logical address or the IP address. Now bridges, how it functions is, okay, they actually know. Now this bridge, now that's what I said, this is the source, this is the destination, means this is the physical address or the media access control address. Okay, now this is quite different than the IP address. IP address I have shown in when I was discussing about the switch and all, those were the IP address. Now this is what is physical address. Now this physical address is in which segment? Is in the 3rd segment. This physical address is there in the 2nd segment. This physical address in the 1st segment. When a packet is being sent to a bridge from the 1st segment, as the packet comes here, okay, as the packet arrives at the bridge, it actually examines for the physical destination address of the packet. Physical destination address, not IP packet. IP address will not be there. Physical what is packet? When the workstation or the computer system sends the message, that message is actually divided into small units of a chunk of data known as the packet, where the packet consists of the source address, destination address, and the actual message to be sent. Now the destination address, since you are talking within the same network, now the destination will be the physical address. Okay, so as the packet arrives at this bridge will examine for its route, its bridge table. It will find out, now this is the destination, now this destination physical address it will find out, but it will also see which segment it is connected. Third segment, the packet will be forwarded directly to the third segment. Packet will first come to this workstation. Since the MAC address doesn't match, it will not accept the data. Instead, packet moves to the next workstation. Here the physical address will match and the data packet will be accepted by this workstation. Okay, this is how exactly the bridge functions. Now bridge is quite smart enough, it knows actually which segment, which computer systems are connected. Now think one more scenario. Okay, this workstation will send a packet where the destination is not there into this network. Destination is not at all there. So it will send a message here. Whereas that packet comes to this bridge, it will examine again for the physical destination address. That physical destination address, it's not there in this bridge table. Then it will block that packet to pass, to forward to any of the segment. It will block, it will discard that packet, because bridge is quite enough smart enough to know that which computers are there onto which segment. That physical address is not at all into their network, means it will discard by blocking that packet. So that packet will never cross the bridge and it will never go to the other side of the networks or the segments. So hence the bridge will functions by blocking or forwarding the data based upon the physical address which is written onto the packet. Now if the bridge believes that destination address is there into this network other than that from which the data was being received, then it will forward to the exact destination by depending upon that physical address. So you can see here a bridge forwards the traffic only to the needed segments, otherwise that packet will be blocked. Here I can say that, see, so many different computers, 4 computers and 7 here 3 computers are there. Now this network is actually divided to maintain the traffic. Now let us consider this has to be the source and this has to be the destination. As the packets arrives to this bridge, it will examine the packet physical address this time. I hope you know what is physical address, and depending upon directly it will forward that packet to the segment 2. It will not check for this workstation address, nothing, because this knows that physical address is there in the second segment. It will forward. The packet may come here, physical address doesn't match. Okay, it will go to the next workstation, address matches, it will accept. What if it, source sends the data? Okay, source sends the data packet. Okay, and now let us consider this to be as the destination. As the packet comes to the bridge, it will has to come to the bridge. It will come to the bridge. Bridge will examine for the physical destination address. It will come to know that physical address is in the segment 1 only. So that packet will forward to the segment 1. The packet will come here, physical address matches, and it will be accepted. What if the destination is not there and this one source is sending the data? Packet comes here, physical destination address that physical address is not existing in this network. Hence this bridge will block that packet. It will never let that packet to cross or move to the next segment. Okay, this is how exactly the bridge works. Okay, then it's bridge is very much simple, and it is very much significant that prevents the network traffic on the segment. Mainly to control the network traffic onto your network, we are using this bridge, and it is helpful to extend our network also. If our network capacity is more, 50 or 100 workstations if are there into our network, then I can use the bridge, okay, so that I can easily maintain the traffic as my network is been extended. So I hope this is all about the bridge you have clearly understood. Okay, one more I can show. This is also the bridge. Now bridge here, it is having 2 ports. Why? One port is connected to this segment, the other port is connected to this segment. Here also you can see how exactly the bridge look like. Here it is 2 ports. Okay, it is very much similar to the switch and the hub. Switch and hub, they are the multi-slot, they are the multi-ports connectors, they are multi-port networking devices. Okay, but whereas the bridge is having very less number of ports, which will just work is to control the traffic onto the network. This is a one LAN network, this is the other LAN network. I hope switch and all, and switch and hub, they all go for the logical address, whereas the bridge will examine for the physical address. So this is how exactly the bridge works. Now let us see the next device, that is the router. Okay, so router usually looks in this way. So router is a device that actually works like a bridge but can handle the different protocols, is known as the router. Okay, so we have seen that bridge is nothing but it's a device that allows to link the two networks together. Same way the router also actually links the two different networks, but it can handle the different protocols, is known as the router. For an example I can give you is, a router can link the Ethernet to the mainframe network. Now when I say that it can link the Ethernet refers to the actually as LAN. Okay, and mainframe actually refers to the server. Mainframe computers are the servers. Now when I say about the mainframe or the servers are having their own network. Okay, so in that case I have to use the routers. Okay, suppose when I request for in my computer system, when I say that facebook.com www.facebook.com login page, when I want, actually your data packet, it is moving right from your network, from your LAN network, and it is going to connect to something known as the Facebook server, which might be the mainframe system or supercomputer, whatever it is, mainframe. That means two different network which are geographically separated. So when your packets are moving outside your network and getting connected to some other network in order to fetch the information, in that case what device you are using is the router. And when the device is accepting, taking your packet and forwarding outside your network and getting connected to the internet in order to fetch the data, in that time the router deals with the different kinds of protocols. It has to pass through different kinds of protocols. Hence the definition says that it's a device that actually works like a bridge but can handle the different protocols, is known as the router. That means what I'm trying to say is, the router is the device that is helping you to connect to the internet. Without the routers we cannot get connected to the internet. When I say internet, that's a different network. When I say to the LAN network, that's a different network. LAN doesn't need an internet. LAN means without having an internet also, we can make the two computer systems to communicate with each other just by having the LAN cables. Without internet also they can communicate. That is what is LAN. Internet, as I hope you know what is exactly the internet. So if I have to connect my LAN network to the internet, I have to make use of the routers. And this router, it is also used to connect to the internet to the corporate world. Now I'll show you this next slide. You can see this is actually the OSI reference model. There are 7 layers in that. So at the physical layer actually the hubs work, at the data link layer switches work, at the network layer actually the routers work. At this network layer there are different kinds of protocols which are helping you to retrieve the IP address, that is the IP address or the logical address. In order to retrieve, it has to deal with the different types of protocols. Hence the definition is the like it can handle the different protocols. You can see here also it is clearly shown. This is the hub which is working at physical, switch is working at the data link layer, network layer, router is working, and apart from this all other rest of the layers, the gateway is working here. It is also a networking device which we'll study in the next topic here. And these are the terminologies what we have to use for our message at the each layer. All these first 3 we have to use as data. When we are discussing about the gateway, we have to use about the segment. When we discuss about the router, I have to use the terminology as packet. When I use a terminology as a switch, we have to use it as frame. When we are discussing about hub, we have to use it as the bits. Okay, that's why we call it as router, is handling the different protocols at the network layer, but which is working, which is helping you to link the two different networks, the LAN network and your internet. Okay, that is why we need the router. Here I can show you here. This is one LAN network. This is one more LAN network. This LAN is connected with the hub, and this LAN is connected with the switch, and both want to fetch an internet connection. If so, they have to make use of the router here. Okay, and one more example I can show here, one more slide. See, this is a LAN network switch. Here the LAN different nodes are there, using which they are connected. If your data has to move outside your network, then I have to use the router. This clearly shows. See, think that this is one organization with a sales department, this is one organization with an accounts department. Okay, this is a LAN. Different sales department have their own LAN network, accounts department they have their own LAN network, and they need to fetch the internet. Both are connected to the router in turn is connected to the internet. I can say now that I have connected by Ethernet to the mainframe network. Now here the server what I am fetching might be my servers, which is maybe the mainframe computer systems. I hope it's you have clearly understood. Now let us see how exactly the router works. Okay, so comparatively to the hubs and switches, okay, the routers are quite smart enough. It makes use of the complete packet address to determine which router or the workstation should receive each the packet next. Suppose I have the source and the destination. Now I'll explain with this one. What they are telling is the routers are quite smart enough comparatively to the hub and switches. It makes use of the complete IP packet address. Now here it is using the logical address or the IP address. Now this, look at this. This is the IP address. In the bridge what I had shown, that was the physical address or the MAC address. Now think that host A wants to send my data, send that data packet to the host B, which is onto the different internet. Now this, consider this is one LAN network where almost 6 to 7 computers are there. In that I am considering this computer to be as the source. Okay, now let us consider this one is the different LAN, different network only. Here also maybe some around 10 systems are there, to which my destination and computer might be with this IP address. Now here I am using a device known as a router, which is helping you to connect the two different in networks. They are not even connected anywhere. If I want to connect these two networks, I have to make use of the common device known as the router. Now this router is also connected with this network. This is a router, this is also connected to this router. Okay, now as the IP packet comes here onto this, when it at the time of when the source actually releases the messages to forward to reach to the destination, what that packet consists of, I want to communicate with this IP address. This is the IP address of your destination. Now as the packet moves here, the router will have to check based upon the routing table. The router will decide where the packets has to be forwarded. There will be many computers connected to this router. Okay, it will check its routing table. Now why it is checking its routing table is because in your packet there is source address and the destination address. Destination IP address is different than the source IP address, but it should make sure that for that particular network I have connected or not. It will check its routing table. All routers always makes use of the routing table, and routers ensure that the packets are traveling the most efficient paths to reach to the destination. In this routing table, what is there? See, firstly it is connected to the one network where the network range is 192.168.5.0/24. Isn't it that this range is being followed in this network? See, 192.165.5.5. It's falling within this range. That means this router is connected to this network. That's why it is accepted the packet coming from this network. If this router has to forward the packet to the destination, it should also make sure that it is connected to this network. In that case, again it will check whether I have connected to that network in order to forward that packet. It will check what's the destination. It is 10.0.0.05, right? So it will check 10.0.00/8. Up to this range it is connected. Hence the router will understand that I have connected. Hence it will forward that packet to the host B or the destination. This is how exactly the router sends or forwards the packet. What does the packet do is, it firstly examine the entire complete packet address to determine where the packet has to forward. Okay, based upon what it is determining? Based upon the routing table. You need not to understand what exactly the routing table, and you should understand how exactly the routing, what exactly the in routing table, how the data is being stored. You need not to worry all about this. Just for your understanding purpose, I'm showing these examples. Okay, and then after this, the routers also make sure that you travel to the efficient destination, efficient path to reach to the destination. Now I'll example one, I'll show you. Think that this is the source, okay, and this is my destination. This is different network and this is different network. In between there will be routers. Okay, in between there will be routers. So as the packet, maybe think that here is one router. As the packet reaches to this router will make sure whether I have connected to this destination or no. If it is connected, there are many paths to reach the destination. Maybe A, B, C, G one path. A, D, E, F, G one path. A, B, D, C, G one path. Like this, many. You can see possible paths from A to G. So many possible paths are there. Routers not only forward the packet, but among this, by using some distance vector algorithms, okay, some different algorithm, based upon that it will find the efficient path to reach, the shortest path it will decide, and then your packets will follow the efficient path. Now A, B, C, G finds the most shortest path to reach to the destination. Hence that packet will take this route in order to reach to the destination, depending upon the IP address and by following the routing table, which will be followed by the routers. Okay, so this is how exactly the router works. Now if a link between two routers fails, the sending router can determine an alternate route to keep the traffic moving. Suppose for example I said that here might be one router, here might be one router, and here might be one router. Similarly here also, there will be different number of routers. Now when I am choosing the path A, B, C, D, a router which is present here, this will be the router first one to receive the packet. It will determine this is the shortest path and I have to forward. Now that router may pass the packet to here, and this may come to this router. The packet may come to the second router. But further, if the link is broken, the link between the router and this node, if it is broken, what this router will do? It will immediately send to the next nearest router. That router may forward that data packet to F, data packet to the router which is nearest here, and this router may directly connect to this link and forward to the destination. Like this, the routers, if the link between the routers and the destination, sending router, if it is fails, then the routers have also capacity to choose the alternative path so that the packets has to reach to the destination somehow. If the destination is unknown to a router, it sends the traffic to the another nearest router. Think that here is the router and this is the destination. Maybe this is some other different network. This router is not directly connected to this destination. This router which is present here is not directly connected to the destination. What it does, when the packet arrives to this router, the router doesn't know the destination address, so what it does is that intermediate router will pass that IP packet to the next nearest router. It will forward the packet to the next nearest router. The next nearest router will examine the IP of destination address. If it is connected to that, it will directly forward that packet to the destination. If not, the router will forward to the next nearest router. The next nearest router, again it will examine for the IP packet. If it is connected, it will forward it to the destination. This is how exactly the routers work. This concept is same like packet switching, which we have already discussed many a time. In switching techniques also I have discussed, correct? Okay, and in ARPANET also I have discussed. Now all this forwarding the packets, everything will be done by the routers. Okay, next thing is a router actually makes use of the logical address as the IP address. One more with a simple example of also I can tell you here. As how I was telling, the routers are forwarding the data to the next nearest router. Think that this is the source. Okay, and this server is a destination. Don't you think that I'm connecting this is a LAN to the mainframe network? So this to connect the two different network, this is internet and this is my own private network, might be a LAN network or Wi-Fi, whatever network it might be. Now how I'm connecting? By using the common device known as the router here. Understood? So when a packet comes to when the packet comes, in the packet what all things will be there? Source address, destination address, and the data to be sent. Now what is my source address? Is this 10.0.01. What is my destination IP address? Is this. Maybe you're requesting the Facebook page, Facebook login page. Then your packet will be first received by the nearest router. Understood? Think it's a network. Now to this network the router has to be connected, because I need a common device which is connected to this network as well as to your internet, right? So when the packet comes to here, this router, what it will does, it will examine the IP packet. Now it will examine this is your IP packet. It will understand right from this node I have received the packet. It will not discard, because it's a genuine packet, because this router is connected to with this network. Yes, where it should go? To this destination. While sending the packet, router what it does, it will change the source address. From here the packet has to move, no? It will change the source IP address and keeps the destination IP address same. Understood? When it forwards the data, it will come to the server. Server will accept the data because the destination IP address matches. When the servers reply back, see that server, now this time what happens? Server's reply will be, what will be the, in packet it will be, source address will be the this one 200 because it is replying back. This will be the source, which will be my destination, actual destination. Server will send to this destination because router has forwarded your data. Correct? Intermediate. So intermediate data will become the destination. When the packet reaches here, the router will examine from where actually the request I had taken from, actually from this IP address. That means that requested packet has to go to the destination. That time again the router will make the modification in the packet and it will assign what? Where its source address is this one, from where I had got the reply, this is the source, and where your packet has to go to the destination, and it will attach the destination IP address and then forward it to the source address. This is how exactly the routing works. When the router, suppose if the router is the common device that is connected between, directly if it is connecting, no, it will like this directly. If this is a common, accept and forward. If your router is not directly connected, in immediate many routers if they are there, then it will change the IP address which is there onto the packets. That means if one link, if it is not there, if a router is not able to access, if IP address, if it is not able to map, then that packet will go to the next nearest router, next nearest to the next nearest router, then reaches to the destination. So this router actually differs from, now I said router and bridge works the same. Then what makes it difference is, a router actually differs from a bridge, that where the bridge makes use of the physical address, whereas a router is using the logical address. And bridge, within the same network, if I have to communicate with each other, I have to use the bridge. And if I want to access the internet, and if you want to transfer your packets outside the network, then I have to make use of the router. Okay, router is very simple. If you need to connect to the internet, then you have to make use of the device known as the router. I hope the routers are clear. Now let us move on to the next device, that is the gateway. A gateway is a device that connects the dissimilar networks. As you can see in this slide, so there is two networks here. One is the LAN network. By using the switch, this LAN network has been constructed, and one more network is the internet, which is WAN. This is LAN network and this is the WAN network, and here we are using a device known as the gateway. So this is the gateway device which is responsible in connecting the two dissimilar network, that is LAN and WAN. So in our when I was discussing about the router also, we have discussed about like a router is a device. It will help you to connect the two networks, but router is the one that also deals with the different protocols. So gateway is the next level of the device apart from the router. The gateway is the next higher level of device, but whatever the functionality of the router does, the more functionality will be performed in the gateway rather than the router. Okay, gateway is performs the additional functionality along with the router's functionality. Some additional functionalities will be performed by the gateway. Otherwise, gateway's job is to connect the two dissimilar network as does the router. Suppose if you want to connect to the internet, I said that you have to make use of the router. Similarly, suppose if you want to connect the two dissimilar network, if it is LAN and WAN, you should also have a by default a gateway, right? Okay, this whatever the router performs, same functionality will be performed by the gateway, but gateway also have some additional functionality to perform, and this gateway actually operates at the highest layer of network abstraction. Highest layer of network abstraction in the sense, as I have already discussed, I have shown in the OSI reference model. In the highest layer here, you can see we have 7 layers here. In the highest layers of application, presentation, session and transport layer, you can see the device which is working here is the gateway. That is the reason we call it as it is working at the highest layer of network abstraction. Other than that, network and all, router, switch and hub, these are the devices which come into picture when we are dealing with these layers. Okay, next. This gateway actually it expands the functionality of router, okay, by performing the data translation and the protocol conversion. Basic functionality of gateway is to connect the dissimilar network, and it also forwards the packet to the destination, accepting the data from the source network to the destination network it will forward. But apart from that, it also expands the functionality of the router by performing data translation and protocol conversion. Now what is this data translation and protocol conversion is? Think that LAN and WAN are having the exchanging the data packets. The LAN architecture, what the protocols and what are the data format it is using, the same data format and the same protocols will not be used by the WAN. WAN in the sense internet. Okay, an example if I take, if there is a communication between the PC and the server machine. PC in the sense your computer system or the workstation. The workstation, whenever it is forwarding the packet or the forwarding the message, it makes use of some of the protocols which we have already studied in the OSI reference model. Those protocols, and it uses the some of the data format, okay, the machine dependent data format it uses in the packet. As the packet moves out of your network, it will reach to the gateway. Gateway, what it does is it performs the data translation. By performing the data translation, it will convert that whatever the data format which was being sent by your source, it will convert into the format which is understandable or compatible to the WAN network or the server machine. The server machine data which format which it will understand, in that format the data translation will be done by this gateway. And a protocol conversion also will be performed. Why? Because your computer system is working with the different protocols which were not compatible with the WAN. So those all protocols with your packet will come here. Gateway, it will understand where it has to go to the destination, maybe Facebook server it has to go. Then it will perform the protocol conversion. It will attach those protocols which are compatible by the server, which is understood by the server, and then your packet will be forwarded with the data translation and the protocol conversion. As a packet reaches to the server, looking at the information on the server will understand what actually you have asked for, because the data has been converted, the data has been translated into the format which the server can understand, and the protocols also will be attached where the server is compatible. Then the server replies back. When the servers reply back to the packet, that kind of data and the protocols are not compatible with your network. In that case, what happens? Again, gateway performs the data translation and and the protocol conversion, depending upon which your network or which your computer systems are compatible. Accordingly, it will convert the data into packet and it will attach to the protocols which are your network can understand and are compatible, and then forward that packet to the source to you. Then you will be able to see the whatever request you have done for the server, that you will be able to see in your computer system. This is what data translation and the protocol conversion. Protocol conversion, I can give an example. Protocol conversion is needed because communication may takes place between the different devices, maybe from PC to server it may take, which may use the different protocols to communicate and which are not compatible with each other. In that case, gateway act as an interface or mediator which is compatible between the devices. That means gateway it is acting as an interface or intermediate because it can understand the data format which your network is using and the data format which the internet is using. So accordingly, it will convert and forward. It will accept the data and forward to the destination. It will accept the data from destination and forward to your computer system. So in gateway here it is acting as an interface. So still more points are yet to be discussed in case of gateway, which we will see in our next video. Till that, take care and thank you.